We are going to continue building from our rational number operations that we talked about previously, and we're going to put all of them together. One of the things that we need to keep in mind is our order of operations. So hopefully this is review, but our order of operations tells us the order in which we need to solve our problems. One of the ways you remember it is the phrase, "Please excuse my dear Aunt Sally," or PEMDAS. Each letter stands for the steps in which we should solve the problems. So P stands for parentheses. E stands for exponents. M stands for multiplication. D stands for division. A is addition. And lastly, S is subtraction. So when you are given a problem, the first thing you're going to look for is parentheses. That means something on the inside of the parentheses is being added or subtracted by something else. The next thing we're going to look for is exponents. That's when we have to the power of. That's a small number up in the corner. Then multiplication followed by division. Then addition and subtraction. Some other things that we need to remember that we've previously learned are our rules for adding and subtracting rational numbers. So the first thing we're going to do is we're going to read our problem either out loud or in your head. And if you say the word minus, that should be a clue to you that you need to rewrite it as addition. And we are going to do that with keep, change, opposite. We've practiced that several times, and we're going to use that to rewrite our problems if we need to. Once we have an addition problem, either because they gave it to us or because we rewrote it, we're going to look at our signs. Same signs tells us to add, and different signs tells us to subtract. Once you do either the addition or subtraction, look at what you have more of and give your answer the sign of whatever you do have more of. Just recently, we've talked about multiplying and dividing rules. So one thing, if you're dealing with fractions, you want to make sure that you turn all of your mixed numbers into improper fractions before you multiply or divide them. You don't need a common denominator for multiplying and dividing, but you do need improper. Then regardless of whether you're doing fractions, decimals, or whole numbers, you're going to multiply or divide like normal. And you're going to check the sign of your answer by using one of the tricks we previously talked about, the good thing, bad thing trick, or the even odd amount of negatives trick. So something that's new that we haven't really talked about yet is something called the distributive property. We distribute something that is on the outside of the parentheses to everything on the inside. And we're going to do this using multiplication. What that means is we are going to take the outside number and multiply it by everything on the inside of our parentheses. So this picture below just kind of shows you the normal way versus the distributive approach. So the distributive approach is what I'm going to talk about. You see that first problem there. You have 5 on the outside of parentheses and 6 plus 2 on the inside. One way to solve that, instead of doing 6 plus 2 first, is to distribute, which means I'm going to take 5 times 6 and 5 times 2. That's going to give me this second row here, which gives me 30 and 10, and I add and get 40, so I'm still going to get the right answer. Even if I were to do it with 3 numbers on the inside of my parentheses, I would still multiply that outside number by each of the inside numbers. Where distributive property becomes a little bit more useful is when we add in some variables, some letters that stands for numbers, and we're going to practice that a couple times in this unit. So go ahead and flip to the other side, and we're going to do some practice. And the first bit of practice we're going to do is with distributive property. So our first example there says to expand the expression using the distributive property and then solve. What that means is I'm actually going to take this outside number and multiply it by each of the inside numbers. So I'm going to take -3 and I'm going to multiply it by 4. Then I have my subtraction sign. And I'm also going to take -3 and multiply it by 5. That is the expanded form when you show that the outside number is being multiplied by each of the inside, that is your expanded form. So when it asks you to expand the expression, that's what you're looking for. But then the second part here is to solve. So I'm actually going to do this multiplication and continue solving. So when I start at the beginning, negative 3 times 4, well, 3 times 4 is 12. And a bad thing happens to a good person, therefore it's a negative 12. I still have my subtraction sign. I'm doing negative 3 times 5. Well, 3 times 5 is 15. And a bad thing happens to a good person, so it's a negative 15. When I read this next step out loud, it's read as negative 12 minus negative 15. As we mentioned, whenever we say the word minus, we want to rewrite it with keep, change, opposite. So I'm going to keep negative 12 the same, change subtraction to addition, and the opposite of a negative 15 is a positive 15. Now you are able to solve this. I know that my signs are different. That means I'm going to be subtracting them. 15 minus 12 is 3, and I have more positives. Therefore, my answer to this one is a positive 3. Our second example is still using the distributive property, but this time it has a variable in it. I did mention that that's going to be where distributive property is most helpful. So I'm still going to distribute, which means multiply my outside number by each of the inside. That means I'm doing negative 2 times 4x, and I have my subtraction sign. And I am doing negative 2 times 5. I'm going to continue multiplying. I have negative 2 times 4x. The x does not change my multiplication right now. I'm going to multiply the numbers. So negative 2 times 4. Well, 2 times 4 is 8. And a bad thing happens to a good person, so it's a negative 8. And then I'm going to keep my x with it. I'm going to have my subtraction sign. Negative 2 times 5. Well, 2 times 5 is 10. And a bad thing happens to a good person, so it's a negative 10. When I read this, it is negative 8x minus negative 10. I said minus, so I need to rewrite it with keep, change, opposite. Now, in this particular problem, this is actually the furthest we can go. In some future units, we'll talk a little bit more about why we cannot combine 8x and 10. The main reason is because they are not like terms. So what that means is I cannot put them together because 10 doesn't have an x. Since both of them do not have an x, I have to leave them separate. They don't go together. So that's going to be my answer for that one. Now, sometimes you're not going to have to distribute at all. Sometimes it's just using your order of operations and what you know about other problems we've done. So this one is 7 1/4 over negative 3/5. It's written like a fraction, and one thing we've talked a lot about this year is how every fraction actually represents a division problem. So this is really just showing 7 1/4 divided by negative 3/5. I am going to have to make this improper to keep going, so I'm going to do 4 times 7, which is 28, plus 1 is 29 over 4, divided by my second fraction, 3 over 5. When I divide my fractions, I rewrite with keep, change, flip, which means multiply by the reciprocal. I'm going to keep 29 over 4, change division multiplication, and flip my last fraction. Again, 3 over 5 and 5 over 3 are reciprocals. That's the flip part. From there, I am going to multiply straight across the top and straight across the bottom. So when I multiply across, I get 145 over 12. From there, I do know that I have an improper fraction here. I need to change it into a mixed number. So if you can do it in your head, great. If not, you're going to set up long division. The top number will go on the inside, the bottom number on the outside. 12 cannot go into 1, but it can go into 14 one time with 2 left over. Bring down your next digit. 12 can go into 25 2 times with 1 left over. Since my problem gave me fractions, I want my answer as a fraction as well. So I'm not going to add a decimal. I'm going to use these pieces to come up with my answer. On the top of the division bar is my whole number, so my whole number is 12. At the bottom, when I was done subtracting my leftover, my remainder, that's my numerator. And my denominator stays the same as it was, or it's what I was dividing by on the outside. So my answer is 12 1/12, but I do need to check my sign. So I had a positive 7 1/4 and a negative 3/5. That means a good thing happened to a bad person. I am sad. My answer is negative. With my other number here, I have negative 6.764 divided by 1.9, and then adding a negative 5.08. One thing that's really important about this is that I follow my order of operations, because there's more than one thing it's asking me to do here. It is asking me to do division and addition. Those are the two signs I'm focused on. So when I think about what comes first in my order of operations, like we talked about in the front, division is going to come before addition. So I have to do my division first. So I'm focusing on this part of my problem. My first number goes on the inside of the division bar. My second number goes on the outside. As we practice several times with decimals when we divide, we want to make sure that our outside number is a whole number. So I am going to move my decimal one time to make it a whole number, and that means I have to do it the same there. Now I'm dealing with 19 on the outside and 67.64 on the inside. I am going to bring my decimal up so I don't forget about it. 19 cannot go into 6. So I'm going to put an X or a 0 for a placeholder, but it can go into 67. It can go in 3 whole times, and 19 times 3 is going to give us 57. That means when I subtract, I have 10 left over, and I'm going to bring down my next digit. 19 can go into 106 5 times, and 19 times 5 gives us 95. So when we subtract, we get 11 left over. Bring down your next digit. 19 can go into 114 6 times, and it just so happens that it goes in perfectly. That means I have 0 for my remainder. I have no other numbers to bring down, and I must be done with my division. When I divided, I got 3.56. I do need to think about my sign, so I go back to my original problem. I had a negative 6.764 divided by a positive 1.9. What I could say to remind myself of my sign is a bad thing happened to a good person. That means it's a negative answer. Now, if I stopped there, I would be wrong, because I still have not dealt with this plus negative 5.08. I need to deal with that. So when I read this problem, I have negative 3.56 plus negative 5.08. Since I said plus, I do not need to rewrite it. I just need to look at my signs. In this problem, my signs are the same, therefore I'm going to add them. So I am going to line up my decimals when I add. And I'm going to add straight down. And I get 8.64. And I look back at my original problem to think about my sign. So I'm looking at this addition problem right here. Both of my numbers are negative. Since both of them are negative, that means my answer is also negative. So my final answer for this one, after doing all of my order of operations, is a negative 8.64. I've got one problem left. I've got 3/8 minus negative 2 1/2 times 1/4. So when you read that out loud, you can really tell what your operations are going to be. I had minus and I had times. When following order of operations, I have to do multiplication first. So I'm going to do that first. So I am going to need to make 2 1/2 improper. So that's going to become 5/2, and it is a negative times 1/4. With this one, I cannot cross simplify, so I'm going to multiply straight across. And I'm going to use my good thing, bad thing trick. This would be a bad thing happens to a good person, so it's a negative 5/8. Now, again, I'm not done. I still have to deal with this 3/8 in front. The next thing that I have not dealt with is my subtraction. But the answer that I got when multiplying was a negative 3/8, so I'm going to plug it in there. Looking at these, I'm sorry, that's a 5/8. There we go. Looking at this problem, I have 3/8 minus a negative 5/8. Since I said minus, I need to do keep, change, opposite. I'm going to keep 3/8, change to addition, and turn my last number into the opposite, which would be a positive 5/8. I am going to make sure I have a common denominator, which I do conveniently. And that means I'm going to add my numerators. 3 plus 5 is 8. My denominator stays the same. 8 over 8 simplifies to 1 whole. And I'm going to go back to my addition problem here. And I actually don't have any negatives in that problem. That means that my answer must be a positive. I have more positives when adding. Please make sure that you check in with a teacher if you have any questions about any of these steps.